Hello, this is Ilya from Gont. Today I want to explain the main technological Gont platform know-how. They are Advanced Multi-Core Virtual Machine or VM for the blockchain, Value Chain Principle and monetizing the computations via alternative gas, and the possibility of hardware protection of calculations and consensus. Okay, so let's start. Gont, in a nutshell, is a technology that employs advanced computational sharding and chains sharding for the blockchain virtual machines with hardware consensus protection. It's not a secret that with the increasing number of transactions, Ethereum began to experience performance difficulties. Sometimes, a simple transfer of the Ether between accounts is delayed for several hours. I cite Ethereum as an example, because Ethereum is currently the biggest blockchain with a virtual machine. In order to solve performance and other problems, even the special Ethereum fund was created to support scalability platform improvements. Scaling blockchain networks depends on the speed of the virtual machine that executes smart contracts. Therefore, VM sharding is one of the main tasks for achieving blockchain speed of up to 10,000 transactions per second. This speed was designated for the Ethereum as the performance target for the platform by its founder, Vitalik Buterin. By the way, this speed exceeds the speed of the network that provides Visa card system transactions. Of course, VM sharding is not the only bottleneck in Ethereum or other blockchain systems. In order to achieve speed of 10,000 transactions per second, you need to remove several bottlenecks. However, the sharding of computations and chains sharding are one of the most important tasks. Computation sharding is the ability of a virtual machine to divide the transactional load in a blockchain by a number of separate computational flows. For example, imagine obsolete computers where all tasks were handled by a single central microprocessor. The entire queue of transactions of all kinds fell on the CPU and they were executed in serial order. In modern computers, a separate microprocessor computes 3D graphics, other video streams, other audio, and so on. Even within a single microprocessor, there are several cores that allow parallel computation. This makes it possible to perform many tasks at the same time, and because microprocessors can be tuned to execute specific tasks, they also manage them more effectively. Like in this case, the main idea of computational sharding and chains sharding by the Gont VM is the creation of a completely new virtual machine with a multi-core architecture and a mechanism to run parallel transactions between the cores. Cores can be tuned by implementing various specialized computations in it, which improves the efficiency of calculations and increases transaction speed. We have called this new virtual machine the Gont VM, and the cores inside are called GVM. The Gont VM consists of an infinite set of GVM cores. Each of them can be run independently or together with other cores, depending on the set of transactions and your specific task. Each core of the GVM has its own set of instructions that define alternative gas, or LGAS. It is the energy needed to execute them. The owner of the kernel GVM determines their commission for the spent LGAS. And when his GVM starts, he gets his commission along with the platform miner that actually launched the GVM kernel. In fact, every GVM has unlimited potential for solving any tasks because the set of instructions and the LGAS cost is determined by its owner. In other words, the user creates a GVM and his digital value is stored inside, described in instructions language. When someone uses his digital value for any purpose, he gets his reward through LGS. However, to create more complex computing microservices, you can build clusters from the required GVM cores by combining them into chains. We called this approach Gont value chain or GVC. We developed a methodology for routing Gont VM in order to implement the GVC model, where a unique computational microservice can be built on the basis of any number of individual GVMs. Each GVM can also describe the rules of exchange with other blockchain networks, which allows solving the task of inter-blockchain exchange on the relay level. From this point of view, Gont becomes a relay-level network for values exchange between different blockchain networks. The old Ethereum VM does not contain any cores. It is quite solid and ruled by one man. Therefore, the Solidity language of Ethereum doesn't have enough functions for our multi-core model. So, we have developed a new language which we called the Gont language or Goal. Goal makes it possible to use complex multi-core structure with routing between the cores in order to create more functional smart contracts, like cross-blockchain smart contracts. For example, where rules are driven by one blockchain and currency transfers are made in another. Okay, some words about the Gont future. Gont VM is a virtual but accurate model of a real multi-core cluster of virtual processors, which makes it possible in the future to convert the GVM cores from virtual to physical processors, which will speed up network performance and reduce transactional cost by several orders of magnitude. The development of Gont microchips will reduce the risks of computational miners cheating, which often leads to the cancellation of transactions, even in leading blockchain networks. In addition, the hardware-based consensus is more resistant to 51% attacks because it allows you to take integrity snapshots of financial transactions at certain points and flush them into a special GVM hardware container. The easiest way to imagine Gont is like a blockchain with a nested blockchain or blockchain of blockchains. This means that with the help of a multi-core approach we can protect the critical vulnerabilities of the core network using separate nested blockchain networks using hardware GVM core. There can be a smaller number of nodes, but they can be much more secure. For example, we can create integrity snapshots for financial transactions and put them in a separate hardware GVM core of the virtual machine. This snapshot stores hash sum for transactions for the period that is the sample. If the network is attacked, we can reconfigure hash with a representative GVM, and if the sum does not match, roll back the changes caused by the hack. Therefore, we can protect the sample with a nested blockchain. The attacker will have to hack not only the main blockchain network, but also the embedded one, which protects the main one. Considering that such levels of nesting can be any number, this makes the 51% attack financially unjustified. So, today we got acquainted with the main know-how of the Gont platform. They are completely new multi-core blockchain virtual machine Gont VM, unique system of alternative gas LGAS for monetization of computations and digital values, value chain model for building microservices, and the possibility of hardware protection of calculations and consensus. Of course, it's impossible to tell you about all aspects of Gont in details in one video. So you are welcome to learn more about Gont technology on the gont.io website. Please read the white paper and register first in the project whitelist to get bonuses and Gont updates. Thanks for your time. Subscribe to our channel to know more about Gont, and good luck!